Hi, this is the lesson for 11.6 volumes of pyramids. Now, in the description, I'm going to add a link to a very neat video that shows you how to derive the equation for the volume of a pyramid. But what I'm going to show you guys right now is kind of like an illustration in an exploration kind of way as to how this equation got developed. So what you have here is a pyramid and you have a cube. Now, both of these have the same base, meaning that this area right here is the same as this area right there. Same area of the base, and also same height. Now, the height from here to here is the same as the height from here to here. Okay, so if you can see here, it takes at least 3 of these to fill this up. And you're going to see that in the following illustration. So if I was to grab this pyramid and put it upside down and fill it up with, I don't know, sand or dirt or whatever, and I fill it all up just like you guys see here, and I start dumping it inside the cube, it's going to take a total of 1, 2, 3 of these to completely fill up. Okay, which means that the volume of the pyramid is 1/3 the volume of the whole cube, and this is true for any kind of pyramid with any kind of base. You can have a pyramid with a triangular base, a rectangular base, a square base, a pentagon, octagon, nonagon, whatever you want. Now, if you end up putting a lot of sides or an infinite amount of sides, then we're going to actually turn that pyramid into a cone, which is going to be the next lesson. So the equation for the volume of a pyramid is the area of the base of the pyramid times the height of the pyramid, all divided by 3. Why 3? Because look, it takes 3 times of these, so 3 of these, to completely fill up one of these. So because I only want one of them, I have to divide it by 3. So that's what we're going to be using. And by the way, this is on page 339 in your journal. Let's look at page 340. Okay, so let's start with a prior example. This is not one of the examples that we're going to be doing, but this is an example I want to show you guys to see how this thing works. So the very first thing I want to do is I want to find the volume of this pyramid, and I'm going to do that by finding the area of the base multiplied by the height of the pyramid, all divided by 3. Now, out of these two unknowns, I know the height of the pyramid happens to be 3 inches. So my goal is to find out what the heck is the area of the base. Now the area of the base, they tell me here that it's a hexagon, and it looks like it's a regular hexagon. So we're going to be using the equation that we learned in the previous lessons, perimeter times apothem divided by 2. Now the perimeter is very easy because the perimeter is just the number of the side length times the number of sides. So if the side length here is 2 and you have 1, 2, 3, 4, 5, 6, 2 times 6, that is going to be 12 times the apothem, all divided by 2. The problem is we don't know what the apothem is. Now I'm going to eyeball that the center is going to be approximately right there. The apothem is going to be this distance right here. So I'm going to create a right triangle, and my goal is to figure out what this angle is going to be right there. So just like I showed you guys, if you grab 360 and divide it by the number of sides, I get 60, and I divide it again by 2 to get this one, and this gives me 30. So I'm going to focus in on that triangle only. That's a right triangle where this degree here is 30, and this distance is half of this distance of 2. So this is going to be 1, which means that the apothem is going to be the long leg across the 60-degree angle. So if you remember, the short leg times radical 3 gives you the long leg. So it's 1 times radical 3, or simply radical 3. So my apothem or apothem, people call it differently, is radical 3. So I'm going to put that there. That's 12 times radical 3, all divided by 2. That reduces to 6 radical 3 because these divide out to give you a 6. Now, that's the area of the base. That's the height of the pyramid. Now what we're going to do is we're going to find the actual volume. So the volume is equal to the area of the base times the height of the pyramid divided by 3. So as you can see, these 3's are going to divide out, and the volume of this pyramid, it's 6 radical 3 inches cubed. Now, if they want an approximation, all you have to do is put it in the calculator. And according to my calculator, to the nearest tenth, I'm going to get about 10.4 inches cubed. So now I'm going to show you guys where the examples are going to go. At the bottom of page 340, you're going to put problem number 1. Turn to 341, and here at the top part, you're going to divide this up into 2 pieces, 2 and 3. If you don't feel like you have enough space, go ahead and use a different piece of paper. And then here at the bottom, you're going to put 4 and 5. Now, I want to show you guys, once again, the volume of a pyramid is 1/3 the area of the base times the height of the pyramid. If your pyramid happens to be like a tilted pyramid, the equation is still pretty much going to be the same. So now the distance from the top vertex perpendicular to the base is considered the height. Here, that distance is not going to lie inside the base, but it still needs to be perpendicular. So this will be the height for that pyramid. So now we're going to go ahead and start our examples. Now, before I do the examples, please make sure to look at the description and look at the video. I'm going to put a link in there for a really good video that explains why this is the equation for the volume of a pyramid. It's a really good video. I didn't make the video, but I always show this video to my classes. Okay, so this is example number 1. It says find the volume of a pyramid. Okay, so once again, the volume of a pyramid is the area of the base times the height of the pyramid divided by 3. Now, the height of the pyramid, as you can see here, that length is 9. So that's going to be 9. Oh, hold on. Let's not do that yet. Okay, so the height of that pyramid is 9. What we need to do is find the base, the area of the base. So we need to identify what is the base. The base in this problem is a triangle. And it's a right triangle, which makes it a whole lot easier because the area of a triangle is the area of the base, which is the base times the height, all divided by 2. So that gives me 24 divided by 2. That gives me 12. I was right. Or you could divide it like that. It's up to you. So the area of the bottom base is 12. So the volume is going to be the area of the base, which is 12, multiplied by the height of the pyramid, which is 9, and then divided by 3. So I'm going to reduce this. That goes in there 3 times. So 3 times 12 is 36. So the volume is 36, and our units are meters cubed. So that's problem number 1. Let's look at problem number 2. It says originally, Caffrey's pyramid has a height of 144 meters and a volume of about 2,218,800 cubic meters. Find the side length of the square base. This is the key word, the square base. So we know that the volume of a pyramid is the area of the base times the height of the pyramid divided by 3. Let's plug things in here. The volume is 2,218,800. You know what I make in a day, right? Yeah, if I make that in a day, I'd be super rich. Now, the area of the base, we don't know what that is, but we do know the height of the pyramid to be 144, then divided by 3. So I'm going to simplify that. 144 divided by 3, okay, that divides to give me 48. So now what I'm going to do is I am going to divide both sides by 48. Okay, so 2,218,800 divided by 48. So the area of the base is going to be 46,225. Now they tell me that this is a square base, which means that in a square, the side lengths are the same. So the area is side length square. So what I need to do is I need to figure out what is that side length going to be. So the easiest way to do that is by simply taking the square root of that value, and I get 215. So the side length is 215, and I should add my units, meters. How do I get this number? Take the square root of that and get 215. Now all these numbers came out really, really nice. They're all whole numbers. They all have perfect squares, so it all came out great. So this is example number 2. Example 3. Find the height of the triangular pyramid. Okay, so once again, the volume is equal to the area of the base times the height of the pyramid, all divided by 3. So in this case, we are looking for this h right there. We are given that the volume is 14, and we're looking for the area of the base. We'll look at that right now, and then divided by 3. Now, let's look at the area of the base. The area of the base, it's triangular, and the base of that is 4, the height is 3. So that's easy. That's 4 times 3 divided by 2. So that's 12. 12 divided by 2, that's 6. So now we know what b is. So that's going to be 14 equal to 6h divided by 3. Now that reduces to give me 2. So 14 equals 2h. So what we got to do is divide it by 2, and my height is 7 feet. Okay. All right. Let's take a look at number 4. Okay. Pyramid A and pyramid B are similar. Find the volume of pyramid B. So you don't really need to calculate actual volumes because you don't know what these side lengths are. You could figure them out if you wanted to, but why bother? Now, one of the things we need to remember is scale factors. K is the scale factor of the lengths. K squared is the scale factor of the areas. And K to the third is the scale factor of the volumes. So that's what we're going to need. We need to find K first. So to find K, I need to do the ratio of the image to the pre-image for corresponding side length. So it doesn't matter which one you make what. I'm going to make this one my pre-image, and I'm going to make this my image, which means that I'm looking for this volume right here. So the scale factor is going to be image by pre-image, so 6 to 8. We're going to reduce that. They're both divisible by 2, and that's going to give me 3 over 4. So K is 3 over 4. So now what we got to do is we need to figure out what K to the third is. So I'm going to have to cube both of these. Well, that's easy. 3 times 3 times 3, that's 27. And 4 to the third power is 64. So this right here, this is my scale factor of the volumes. So the volume that I do not know is V. The volume of the known one, the pre-image, is 96. If I knew what this was and reduce it, it should reduce to 27 over 64. 64, not 24. So now what we got to do is we need to cross multiply. You're going to get some large numbers. That's okay. 27 times 96. That gives me 64V equals 2,592. So then with this value, we're going to divide that by 64. And I'm going to get the volume to be approximately 40.5 meters cubed. So this was example number 5. Let's go ahead and do the last problem, example 5. In example 5, it says find the volume of the composite solid. So composite solid pretty much just means that you have two solids either stacked on top of each other or taken out of the diagram. So we have two solids. In this case, we have a cube and we have a pyramid. So I got to find the volume of that and the volume of that and add them together. The cube is really, really simple because it's the area of the base times the height. So it's 6 times 6, that's the area of the base. And the height of that cube happens to be 6 again. So the volume of that is 36 times 6, which is 216. Now that's the volume of the cube. And units, meters cubed. Now we got to find the volume of the pyramid. Now you notice that the base of that and the base of this is the same thing. So the volume of the pyramid is the area of the base times the height of the pyramid, all divided by 3. So the area of the base is 6 times 6, which is 36. And the height of the pyramid happens to be, again, 6. Lots of 6s. So that's going to be 36 times 6, all divided by 3. So 36 times 6, all divided by 3, gives me 72 meters cubed. So that's the area of the bottom. That's the area of the top. And now all I have to do is add them together. Okay. And the volume of the whole figure is 216 plus 72. So that's 288 meters cubed. Now, don't forget to do your online homework and the extra practice for this section.